schematic, parts list, all of the parts, and required tools to build it. On your soldering tool, adjust it to about 300 degrees. You won't need this. Keep this tip. This is the tip you're gonna use for soldering. This is your spare. Whenever you need to solder something else, you can use this. Okay, this is your flux. Your solder. This is wick. Whenever you need to remove a solder from the board. X-Acto knife, some clipper, and this sponge. You wetten it, and whenever you need to clean the tip, you just clean it against this sponge here. This is to open up the holes. So sometimes if you install incorrect component and then you need to remove it, with this you heat it up from the other side and you push it through, and that's how you would open up the holes. Your BMS, battery management system, I already installed this connector for the battery, and on AC DC to DC boost converter, you're gonna need to remove this blue resistor and install a 107 kilo ohm resistor instead. That's what we're gonna do the first thing. Let's desolder this blue potentiometer and let's install 100k resistor across this lid here and here. Across these two we'll install the resistor. So I'll go ahead and desolder this. Okay, remove the resistor. Now we're gonna open up the holes. These two, this hole and that hole, and you do it like that. You push it on this side. You see, and you do for another one just like that. Okay, once you open up the holes, we'll put a resistor, 107 kilo ohm resistor in here. So bend it, 1, 2, put it in here like this, and we're gonna insert it about that much, just like that. Put it in the middle, and we'll take our solder, okay, then take a clipper and remove, and just like that. Then you bend it over, and this is ready to go. Okay, next let's move on to the printed circuit board. This is the back side here, this is the front side. Let's start with resistors. So each resistor is marked. This is R7, R10, R2, R1. That's 2 diodes, R9, R4, and so on. Let's start with R7. Now if we look at the circuit here for R7, which is this one here, it's through-hole resistor, 1 watt, which is the larger one, 870 ohm. Okay, so if we look, let me find the resistor, 820 ohm, 1 watt resistor. I'm gonna remove this, bend it over like this, and let's install into the board just like that. Okay, and so on. Just follow parts list and whatever number of the resistor on the board here. So the next one is R10. If we look on a circuit here, so R10 is this resistor here. It's 150 ohms resistor here. So let's see, 150 ohms is this resistor here. Remove the label. Take our board, bend it, insert it into here, and solder. Okay, I'll go ahead and do the rest of them. You got an idea for the resistors, and we'll show you when I get to the diodes and other parts. So let me finish installing resistors. After installing all the resistors, next we're gonna install this potentiometer. It goes here on this corner where there's 3 holes, and capacitor, which goes over there. So let's go ahead and do it. Snaps right in there. And capacitor. Okay, next are the diodes. On a diodes, if you see one side here has a black line. Black line is cathode and the other side is anode of the diode. So we have to follow, just like on the board here, there is a line for cathode, this top one line is on the left side, the bottom one line is on the right side. So we're gonna follow markings from the board. 1, 2. So the bottom one will go like in here like this. You see we installed black line on one side matching markings on the board, and for this one we're gonna match the markings, and the black line is on that side, on the left side. Next is gonna be a chip. So if you look at it on a board, you have a dot here on one side. This indicates number 1, and there's 8 pins. So 1, 2, 3, 4, 5, 6, 7, 8. So this is number 1 here on the bottom right. And if we look on a chip, the chip has a dot as well here. So this indicates that this is number 1 here. So we have to match this number 1 dot with the board. So that will be placed like this. Like that. So your number 1, your dot is on the bottom here. This is number 1. Let me solder it. One quick tip: I usually bend legs a little bit that way on this side and legs bend this way. This way chip stays in there, it doesn't fall out, and it's easier for me to solder it. Okay, moving on, let's go ahead and solder these connectors. 3.5 millimeter jack, there's 2 of them in here. So these are the components, and we're gonna solder them into here. So one goes here, another one goes here to the top, just like that. The tip when you're gonna be cutting off these pins, these edge ones cutting off just fine, but this one is strong, so use the back of your clippers, otherwise you're gonna mess up your so all the way to the back like this, and then maybe like that. Yeah, Next, we're gonna do transistor here, Q1. So Q1, there's two of them in here, similar looking, but one is transistor and another one is a chip. So chip is going to go over here and transistor is going to go here. So chip mark as U2, and if we look on parts list, so U1 and U2, it's a voltage supervisor right here, integrated circuit. So let's look at the markings. So this is 337. Let me zoom it in. Yeah, so as you can see, this is BC337, this is transistor, and this is the chip MCP 100. Okay, so MCP 100 is gonna go here, and then you have to look on the image. So you see it's not completely round circuit, it's a cut off round circuit. So similar way on here, if you look, it's not a complete circuit, it's a cut off. So you match this with that. So this is gonna go like that inside here. Like that. You can bend out edge ones, I'll keep it in there. Transistor is gonna go here. You match it to the markings on the board the same way, just like that. Push it in. Don't have to push it in all the way. This is good enough, but I'm gonna go ahead and push it in all the way, and then I'll bend out first and last pins so it stays in there, and solder. When you solder this, be careful, don't solder in between them. So they're so close together on both of them, so be careful, don't solder. If you do solder by accident together, you can use this wick to remove any excess solder to make sure they're not soldered together, the pins. So let me go ahead and solder it. Okay, next we're going to solder this large potentiometer with on-off switch. So the way you do it, first we're gonna apply solder here, 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 and here. On all these points we're gonna apply solder from one side. Don't worry about these holes here. So 1, 2, 3, 4, and 5. Like that. Like that. Makes a small dome with the solder. This one synced in. Okay, now we're gonna do the same thing here. we're gonna apply solder, a little bit of solder here. 1, 2, 3. 4, 5, just like that. Now we're going to, let's remove this wheel. Just a second, let me grab a screwdriver. And then we're gonna place it over here, just like that. Center it. Just like that. And solder. What I usually do, I take X-Acto knife, I'm not sure why it fell out. And then I would push it in one by one. Yeah, it's not in the center. I'm gonna have to remove this and redo it because this joint, this point is not lining up with this. So I can see there is a gap here on the top and there is no gap here on the bottom. So I need to center it. So I'll go ahead and remove it and recenter it. Okay, I resolder it. Now it's more or less in the center. Like this, in the edge. You can see the gap here all around is about even. So now it's in the center. Okay, next we're gonna do LEDs. So there's 3 LEDs, 1, 2, and 3. Here, each LED markings have plus and minus. So plus on one side. So if you can look in here, there is a plus here, and then there is a plus here, and on this LED there is a plus here. So if you take LED, each LED has one leg which is longer than another. You can see. So the longer leg is a positive. This one on the top is positive. Same thing for blue LED. This clear one is a blue LED. The one on the top is positive. And red blinking LED. The one on the top is positive. So each LED will need a spacer. You have 3 of these spacers. So let's install a spacer on each LED. A yellow LED is going to go here, plus to the left, just like that. Okay. So you need to hold it with your finger, pushing it flat to the board, and then solder it. I'll go ahead and do that. This is blue LED, red and yellow. Have them all installed. All right, let's see. That's about it for the board. Now we're going to, let's see here. Okay, battery. I will go ahead and pre-install the battery to each of the case before I ship it out. So battery, on the back of the battery, battery is going to be glued to the case, and on the back of the battery there's going to be a double sticky tape installed here like this, and then battery is going to be installed on here on the bottom of the case, and on the top of the battery we're gonna install this double sticky tape with the foam. We actually need 4, so I'll go ahead and do that. It's gonna look just like this. Underneath a battery there is a double sticky tape, and this is also double sticky tape, but we're not gonna remove the top of protective paper, so it looks like this. Basically that's how it's gonna look when you receive it. It will be already installed here inside the case, so you don't need to worry about installing the battery. Okay, this circuit is going to go in here just like this. My bad, the other way. But before we install it, we're gonna attach wires. There's gonna be one wire go to here, one wire, 2 wires here, and 1 wire to that hole right there. So 4 wires. If we look on a schematic, these are the 2 wires that would connect from the circuit: 30 volt DC in and ground, which are this one here, 30 volt DC. So this is ground, which is this one ground, and this is 30 volt and ground. And then input is that pin right there, that hole, and this is the output here. And on a circuitry, this is out and this is input here. So let's go ahead and attach the wires. We have some wire available with the kit, so I'll open it up. And attach it. So one from here, out is to the BMS. Actually, yeah, used to be about this long. So you cut it here about 2 inches, a little over 2 inches. So from here to here, just like that. Let's install it. So you're gonna need to strip the wire. You can use this cutter to strip it. And like this. Twist it. Install. Solder. So that's input in, and another one from here to about the same length, about here. Cut it, strip it, insert, and solder. So these are the 2 wires for in and out, and then other 2 are gonna go to here. So let's strip them also. 1, 2, cut this wire in the middle. 1, 2, just like this. Okay. Next, we need to look at the schematic and see which wire connects to where. We have our DC boost converter, which is this part here. And so just follow the wiring, ground to the bottom here, 30 volt DC to the top. So this is gonna be these 2 wires here, these 2. The one on the bottom is GNG, ground, and the other one here says 30 volt DC. That's the one that will go to the output here on the left top, the module. Now module is going to be installed. Let's see how it's gonna be. It's gonna sit here. Like this. So we need to shorten it shorten the wires so they will reach to those two terminals there. We don't need extra wires. We can leave it a little extra, but no point. So let me go ahead and solder it. Okay, like this. V out minus minus, V out plus are gonna go to the board just like that. And yeah, this is going to sit facing this way like that. Now we have BMS here, another module. This module will be all the way on the edge here, sitting and with the port sticking out to the side. So we need to, this module has P plus and P minus. That's a power minus, power plus. So power plus, if we look here, power plus is output plus here. This is minus. So plus is going to go straight into the board where it says input. So on our board here we have input on this side, says IN, that's input. So this wire here is going to go to BMS plus, which is to here. It's gonna solder. Okay. Now V out is going to go to V in plus on a boost converter. So this is our boost converter. We have V in plus, so this V out is going to connect to V in plus. Okay, V out connects to V in plus. Now we have V minus and P minus. These two will need to connect. Let's see here on a circuit. B minus, battery minus, connects to V input minus on a boost converter. So we need to connect these two. And I'm out of cable. Let me grab a piece of wire, short piece of wire. Let's go ahead and connect them. Okay, I connected V minus from the boost converter to the P minus on a BMS, battery management system. Now we can go ahead and test the circuit. So let's connect our battery. And by turning wheel, we have a blue light comes in. This is normal for red light to blink instantly, and the red light is a low voltage battery, blue light is power, and this is colloidal water LED. So whenever you use it on here, so far visually seems to be working, but we need to connect the wires and test it. Okay, let's package it all inside here. Okay, here is how it's gonna look when it's all inserted inside. BMS here, connection USB-C, DC to DC boost converter sits there just like that, and when we close it, we'll just fold these wires here on the side. Let's check it again. Power comes up, looks good. Okay, now we're ready to close. This is the top lid, and as you can see, there is a supporting supports here. These supports are gonna be pushing BMS board. Another thing, guys, I forgot to do, take your X-Acto knife and these two supports here, you need to cut off just a little bit off, maybe 1/16 of an inch off on both sides, like this and like that, and this side here too. Like that. And go ahead and close the lid. Just watch out for these supports, make sure they're in line and pushing right on the boards, so boards like this, staying in there evenly, straight, and go ahead and close it up. Then you should have in your kit, you'll have 4 screws. Just use them here on the sides to close it up. Another thing I do, because sometimes it's not perfectly closing, there is a little gap here, so I would put a little bit of super glue and then I close it like this and hold it, wait for super glue to dry, and then it's completely closed. It's 3D print, not always perfect, so that's how you build it. With the kit, you'll have this wire. This is the wire which is used for colloidal silver. Let's see. Yeah, I have yellow. And same wire is used for micropulsing. Try not to short them. It's okay if you do short them, but try not to short them. A quick test on an oscilloscope. Okay, we have 3.2 Hertz with 28.5 volts. And if I switch to the colloidal, on the colloidal side we should have DC voltage. There we go. We have 28.5 volt DC. Seems to be working good. By the way, this resistor here, R11, is the frequency adjustment, and I kind of forgot to adjust it to get to close to 3.8 Hertz. Right now it's 3.2. You would need to turn that counterclockwise all the way to the end, and that will land you close to 3.9 Hertz. And 3.2 Hertz is fine too, but ideally we want to have close to 3.9 Hertz. So that variable resistor, the blue one here in the corner, is your frequency adjustment. Alright guys, if you like the video, give me a thumbs up, subscribe, and I'll see you in the next one.